NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new.
Oumuamua, a strange interstellar object, left astronomers puzzled when it first appeared. But now, NASA's James Webb Space Telescope, JWST, has unveiled the mystery by capturing the first true image of this enigmatic traveler. Could it really be of extraterrestrial origin, as some suggest? Join us as we uncover Oumuamua's secrets and reveal the startling truth. What does this discovery mean for our understanding of the universe? Discovery of Oumuamua. On October 19, 2017, a peculiar object named Oumuamua was detected racing through our solar system. This asteroid had been traveling for over a century before its discovery. Though it reached a significant cosmic milestone in 1837, astronomers missed it. Oumuamua passed through our solar system over several decades, and despite its constant speed, it went unnoticed until 2017. Robert Warwick from the University of Hawaii spotted it as a faint, elongated trace in the sky through the Pan-STARRS 1 telescope, revealing an unprecedented fast-moving object. Initially, scientists thought Oumuamua was a comet due to its strange behavior, but later identified it as an asteroid, a small rocky body from the asteroid belt between Mars and Jupiter. However, further observations showed Oumuamua was departing the sun unusually fast, deepening the mystery. The absence of visible outgassing puzzled scientists since Oumuamua's acceleration didn't match predictions, leading to debates about its classification. One of Oumuamua's most striking features was its consistent brightening and dimming every 7.3 hours, suggesting it was tumbling and spinning around its shorter axis. This fast rotation implies that Oumuamua is a solid object, more durable than the typical loose, brittle comets. Its dark red hue, akin to some outer solar system moons, indicated it had been exposed to cosmic radiation for millions of years, altering its surface. As specialists analyzed the data, theories about Oumuamua's nature emerged. Some speculated it might be an advanced alien probe or a decommissioned spaceship, while others proposed it could be a new type of comet or asteroid. More conservative theories suggested it might be debris from a catastrophic event in another star system. There is still no consensus on Oumuamua's true nature, as it continues to move away from the sun at a steep angle. Estimates suggest it is heading back into interstellar space, continuing its solitary journey through the universe. Theories around Oumuamua. The discovery of Oumuamua in October 2017 sparked intense debate among astronomers, scientists, and the public. This unique cosmic object, the first of its kind, led to numerous theories about its origins and nature. Was it just a regular space rock? Or could it be an alien probe exploring our solar system? Initially, astronomers thought Oumuamua was a stony asteroid, but its unusual elongated shape, about 800 meters long and just 80 meters wide, didn't match any known asteroids or comets. As more data came in, theories evolved. Some suggested it might be gas-filled, explaining its unexpected acceleration away from the sun. Then, the idea arose that it might not be natural at all, but an alien spacecraft. This notion was bolstered by its unusual non-gravitational acceleration, which typically comes from outgassing in comets. However, no such outgassing was observed with Oumuamua. The idea of it being an alien probe intrigued many, though it seems more like science fiction to some. Theoretical physicist Dr. Michio Kaku proposed that Oumuamua could have been ejected from a distant star during a supernova. Billionaire Elon Musk suggested it might have formed from a collision between two celestial bodies, creating its distinct shape. Initially, astronomers noted that Oumuamua's trajectory seemed to point towards Vega, the brightest star in the Lyra constellation. They estimated it might have taken around 600,000 years to travel from Vega to its current position. However, this theory fell apart when it was discovered that Oumuamua's path had changed during its journey, suggesting it had passed close to another star system before entering ours. Its speed indicated it had likely traveled across the Milky Way for billions of years. Another intriguing theory is that Oumuamua could be a chunk of nitrogen ice. Researchers Alan Jackson and Stephen Desch from Arizona State University propose it might be debris from a Pluto-like object blasted off by a massive impact. For this to be true, Oumuamua would need to be much smaller than initially thought. Despite this, the nitrogen ice theory remains popular as it explains both its composition and its strange acceleration. Beyond your imagination, one of the key discoveries about Oumuamua came when it was found to be traveling in a hyperbolic orbit, a boomerang-shaped path. indicating it wasn't from our solar system and would never return. This led many to believe it would disappear into space forever. Yet, its behavior defied expectations. Notably, Oumuamua sped up unexpectedly as it neared the sun. While gravitational forces from planets and stars can speed up objects like comets, they can't fully explain Oumuamua's acceleration, which reached 54 meters per second, about 3 times faster than the average comet. This anomaly led experts to reconsider its classification as an asteroid and suggest it might be a comet. Typically, comets accelerate due to outgassing, where ice sublimates into gas, creating extra momentum and visible tails. However, Oumuamua had no such tail. Despite this, scientists explored the possibility of hidden forces influencing its behavior. Jennifer Berdner from UC Berkeley and Daryl Seligman from Cornell proposed a novel theory that cosmic radiation outside our solar system might have triggered the release of stored hydrogen in Oumuamua's ice. As it warmed in the solar system, this hydrogen could have created the force needed for its observed acceleration. Their theory is supported by decades of research showing that cosmic rays can break molecular hydrogen from water ice. Seligman believes this explanation is more plausible than earlier, more speculative theories. However, not all scientists agree. Avi Loeb from Harvard, who once suggested Oumuamua could be an alien spaceship, argues that Berdner and Seligman overestimated the hydrogen content due to errors in their temperature calculations. According to Loeb, there wouldn't be enough hydrogen to account for the observed acceleration. With Oumuamua now out of reach, its true nature remains a mystery. Seligman hopes that future interstellar discoveries will offer more insights. New telescopes expected in the next decade may help answer questions about such objects. Meanwhile, recent findings suggest Oumuamua might have a companion object, raising new questions about its journey and whether it could indicate a new understanding of cosmic events or hint at something more unsettling. Oumuamua trajectory. Scientists have suggested sending robotic probes with sails to study Oumuamua's peculiar behavior and unknown origins. However, current technology, including early-stage projects like Breakthrough Starshot, isn't advanced enough for this. Although tracking Oumuamua is currently unfeasible, its brief visit has provided valuable insights for future encounters. Having traveled billions of years, Oumuamua's journey through up to 20,000 star systems has left it dust-laden. Researchers, including Elon Musk, speculate Oumuamua may be headed toward the Kuiper Belt, but its exact trajectory remains unclear. Mathematical models and limited observations attempt to estimate its path, but tracking is difficult. Oumuamua's unusual acceleration is a major mystery. Unlike typical celestial objects driven by gravity, Oumuamua's speed suggests other forces. Dr. Michelle Bannister proposed outgassing like a comet could explain this, but no signs of outgassing or CN gas were detected, implying it may be chemically unique. Attempts to detect thermal emissions with the Spitzer Space Telescope yielded no clear results. The lack of detectable emissions and gas complicates classification, leaving Oumuamua an enigmatic object. Despite speculation, including theories about a possible collision with Earth, data mostly disproves these claims. Meteor. 6 months before Oumuamua's close encounter with Earth, a 3-foot interstellar meteor, IM-2, crashed into our planet. Though unrelated to Oumuamua, Harvard scientist Avi Loeb took an interest in IM-2. He proposed that an artificial interstellar object could act as a mothership, releasing smaller probes near Earth, akin to how NASA deploys spacecraft. Loeb and Sean Kirkpatrick of the Pentagon's ARO explored this idea, suggesting these small probes, driven by natural forces like solar radiation, might be too faint for our telescopes to detect. They could enter Earth's atmosphere with technology that slows them down, potentially landing safely. Loeb theorizes that extraterrestrial civilizations might have sent probes to explore rocky worlds like Earth, Mars, and Venus. These probes could continue their mission even if their creators are no longer around. Loeb's suggestion that Oumuamua might be an alien spacecraft has faced skepticism, with many scientists arguing it is a natural object. A 2021 paper dismissed the idea of interstellar travel due to the immense timescales involved, proposing that Oumuamua was likely an unusual rock rather than an alien probe. More recent research attributes Oumuamua's acceleration to hydrogen off-gassing. Despite the skepticism, the Pentagon's All-Domain Anomaly Resolution Office has intensified its investigation of unexplained aerial phenomena, initiating over 360 new cases involving U.S. military personnel. Half of these have been attributed to balloons or other identifiable objects, while the rest remain unresolved due to insufficient data. Wormholes. To unlock the mysteries of interstellar space and study objects like Oumuamua, we need to better understand dark energy and cosmic phenomena. A spacecraft mission to Oumuamua is tempting but difficult due to its high speed. It's set to pass beyond Saturn's orbit in just 2 years. Current spacecraft can't reach these speeds, so could we use advanced technologies like solar sails, or even speculative methods like wormholes? Humans have an innate drive to explore space, unlike most Earth creatures. This raises questions about extraterrestrial civilizations. Could they be as uninterested in space as many animals are? Despite the universe's vast age and our short history of detecting alien signals, we may be just beginning to scratch the surface. The Fermi paradox highlights the gap between the high likelihood of extraterrestrial life and our lack of contact. With billions of stars, many potentially hosting life, advanced civilizations should exist. Yet, we have no solid evidence, leading some to question the value of continued projects like SETI. Enrico Fermi's famous question, "Where is everybody?" might be misunderstood. Despite technological advances, we still face unknowns. Hypotheses suggest civilizations might be too distant, lack communication technology, or choose to stay hidden for survival. The dark forest theory proposes that civilizations might remain silent to avoid detection by more advanced or hostile races. Alternatively, alien civilizations might be so different that we can't understand them, or humanity could be among the most advanced, missing signals from emerging civilizations. While the idea that we are alone seems less likely, proving otherwise remains a challenge. It's crucial to consider that extraterrestrial civilizations might be at a similar or lower technological level, making their attempts at communication too rudimentary for us to detect. I hope you enjoyed our video. Don't forget to subscribe to our channel for more educational content like this. Thanks for watching.